Okay, so again, we're going back to 2.1, we're finishing here. And I did say get your calculators out because we are going to be doing some graphing. So I think I've got 4 or 5 of these problems I want to get done. We'll see what I can get done in this little time period, okay? So you will need a calculator. Make sure you close that as you walk in because it's a sound wave. Thank you, guys. Perfect. We are talking about finding maximum area. So we are going to talk about maximum area, and we're also going to talk about perimeter as we do this, because when you do perimeter and area, you have 2 variables. Can you remind me what's the formula for a perimeter of a rectangle? Length times, no. Perimeter. Good. Length plus width plus length plus width. We're going to graph them. We're going to substitute it and graph them in the calculator. So 2x plus 2y. I was there. Wow, you were there. What about area, coach? You know area of a rectangle? Oh, no. Close that door tight behind him. All right, area. Now I want that, Rosie. What's area?
Length times width.
Length times width. You came in so hot with that length times width with perimeter.
So ready.
Okay, so we need both of these formulas because we're finding of all of the rectangles whose perimeters are 100, we want to find the one with the dimension with the maximum area. So if I think about this rectangle right here, or any rectangle, pretend that looks nicer, we're just going to let that be. My perimeter is 100, okay? So we actually know what perimeter is. We don't know length, we don't know width, but we do know perimeter. In each of these cases, I'm going to give you area or perimeter. We're going to plug that in and then solve for either variable. I don't care which one it is. So I'm going to take that perimeter formula and I'm going to plug 100 in for that perimeter. So I'm going to say 100 equals 2L plus 2W. Now, we're not going to be able to find out what L and W are alone, but we can isolate one of those variables, okay? I truly don't care which one you isolate. I don't like L in my equation, so I'm going to minus 2W from both sides and then divide by 2 to get L by itself. But it would be the same if you did W either way. 100 minus 2W equals 2L, and then divide everything by 2. So 50 minus W equals L. Now we're going to take this expression for L and we're going to substitute it into my area formula. So instead of area being length times width, it's going to be 50 minus width times width. So my area formula now is going to be 50 minus W times plus W. What we're going to do now is we're going to graph that and find the maximum. Okay. So that's why I had to get your calculators out. I may even make a little note here, graph and max, just so I know what I'm doing. So if you didn't hear me say get your calculators out, now is a good time for them. You can distribute this. I had someone who kept trying to distribute with like FOIL out the box problem. I just think that that's way harder than it needs to be. I'm just physically going to type what I see, 50 minus X, that's my variable, times X. I will tell you your window is going to be a little bit funny here. You're going to need a much bigger window than maybe you're expecting. You don't need any negative numbers. So my X min and my Y min are both 0. Bless you. And I'm going to expect my Y max, I don't know, let's try 500 and see. That might be too big, but I would rather be too big than too small. Oop, it looks like I'm way too small. Do you see how we're getting towards a maximum, but we don't see the rest of the graph? It actually looks like I need a lot more on my X's and a little bit more at least on my Y's. So let's make our X's, I don't know, like 30, just so I ensure that I can see the graph. Do you hear how every time I'm giving you a number, I'm just like, I don't know, I'm picking numbers. So there's no real science behind this, but I didn't see it at 10, so I've got to pick a bigger number. So I'm going to try 30, and maybe we'll try 700 now for my Y max. So I'm going to go ahead and press graph on that. We're getting there, but we still don't see it. I guess I see my height. I don't see the rest of my graph. Let me get it a little bit longer on my X max. Let's go 50 and see if we can see. Ah, there we go. Now I see that nice upside down parabola looking thing. Technically on the last one I could have been done because I did see the peak, I did see that maximum, and it says find the max. So let's go second trace and find our maximum. And we'll go left bound, right bound, find that maximum. And that is at the point 25, 6, 25. Which of those is my maximum area? The X or the Y? Which one? The Y. The Y is always your area, volume, all that stuff. That's your maximum area. What 25 is that variable we plugged in for X, which we used W for. That's your width. That's the width of the shape in order to get this. So it would be 25 for my width. Could we find out what my length would be? Yeah, just plug it in. We can plug it in right here. We can do 50 minus 25 equals L. And so L is just 25. So basically it's telling me that in order for it to have maximum area, it should be a square. It should be the same width and the same length. Okay. We feeling okay about that? I'll zoom back out a tiny bit. So we use area and perimeter in order to solve that. Okay, let's do the next one underneath that. Okay. This one says, Julie Stone designed a rectangular patio that is 25 feet by 40 feet, okay? You can even take that picture that's written there, drawn there, I can do 25 feet by 40 feet. Maybe I'll do it better. Okay, that's like the patio, the little stone pieces. It's surrounded by a terrace strip of uniform width. So these are all the same width. Those are the same distance. Planted with small trees and shrubs. If area A of this terrace strip is 504, find the width of each strip. So we know that the area of like where all the flowers and plants are, that's 504. We want to find the width of that strip. Okay. Now you could break that apart into smaller pieces, but I feel like that would be more confusing. What I want to think about is we can think about the area of the whole minus off the area of the smaller piece. And that gives us the area we want. So the area of the terraced strip is going to be equal area of the whole minus area of that concrete patio. It's going to be a lot easier to take the area of a big rectangle and of a small rectangle than of kind of like that weird like frame all the way around. Okay. Now, we actually know what the area of that terrace strip is. That's 504. That's awesome. And I think the area of the patio is probably the next easiest thing to do. We know that the patio is 25 by 40. So we're just going to throw that in the calculator. 25 times 40 is 1,000. So I'm going to say minus 1,000 right here. Now, the area of the whole piece, the patio plus the terrace strip, is going to be a little bit difficult to find, a little bit harder. I want to zoom in on my picture. Notice that in all directions, I put like that's my width and that's my width. Now, we know, I guess I could even move those over a little bit for that maybe to make more sense. What if I moved it over here and over here? That's still telling me the width of that like bottom or that top part, but I just moved it to a spot that I think is more convenient because now I know that this piece is 25 plus a W plus another W. So that means my new width or my new length of this side is going to be 25 plus 2W. Using that same concept, what's my other side going to be measured now? This one was 25 plus 2W. 40 plus 2W, awesome. 40 plus 2W. Now, the area is going to be multiplying those two together. So we can say 25 plus 2W times 40 plus, we're running out of space, let me move that. Plus 2W. Okay, you could clean this up. And actually on my paper, I've got all this algebra of us like foiling this out and combining like terms. But remember a minute ago when I just said you could put it in the calculator? We could put this in one of our y's. We could put this in our other y, and we can see where they cross, and that will tell me what w equals. And honestly, I don't really feel like doing that algebra today, so that's what I'm going to do. We'll put this one in our y1. We'll put this one in our y2. The only thing you have to do is be really careful about your parentheses, okay? So I'm going to erase this. I'm going to go parentheses 25 plus 2x, end parentheses, start new parentheses 40 plus 2x, end my parentheses minus 1,000. Don't forget that minus 1,000. That will change your problem. And then 504. Okay. My hope is we were just doing kind of a funky word problem, so I'm going to hope that my window is going to be kind of okay. Is everybody okay with what I put in the calculator so far? Okay, I'm going to go graph it. Okay, not terrible, but let's go. Let's see, if I go a little bit higher, do we think we'll see any more of the graph? Let me make my window just a little bit higher. Let's maybe make it 2,000, just in case we intersect again. Okay, I actually like going to this bigger numbers. Do you see how the graph kind of looks like it's like paraboling up the other way? Like it's not bending down like it's going to like be a polynomial graph. It's kind of bending up this way with that intersection. So that to me means it's not going to come back down. If it looked more like this, that would look like there's a peak that we're going to pop back down for, and we're not going to. Also, if my area is 504, my like terrace strip couldn't be much more than 50, or else it would get insane numbers. So I actually think this is the only point of intersection that we have. So let's go find that. We'll go second, trace, intersect, and do your first curve, second curve, or left bound, right bound. And I found my intersection. Oh no, don't play with me today. This eye pencil is on the fritz. I know it's not an eye pencil. Just let me be. Okay. My intersection point is at 3.5504. We wanted to find the width of my strip. Which of those is the width? 3.5, good, my X, that's the width of my strip. So we did it. Okay. 2 down, 3 to go. Okay. Let's jump over to the next page. I just want to do 58, 59, and 62. And let's actually jump and do 62 first, and we'll not do 66. I just don't feel like that. 60 or 58 and 59 are almost the same. So if I don't get to one of them, I'm not going to stress about it. 62 is talking about this little league. They have this baseball throwing machine, and it throws the baseball straight up with an initial velocity of 48 feet per second from a height of 3.5 feet. Okay. If I give you a problem like this, I will give you an equation to start with, okay? I will maybe have you plug in a couple of those numbers, but I will give you a base equation. I will not expect you to memorize this base equation. So for today, the base equation that we are using is going to be y equals negative 4.9x squared plus v sub o x plus s sub o. I'm saying v and then sub, like a submarine, it's below, that 0 is below. What those sub-0 numbers mean is the initial of that. So v stands for velocity, so I want the initial velocity. And what do you know? They told us that. So we're going to plug 48 in for that v sub o. And then my s sub o is for my initial like place or my initial height. I could give you on a quiz or a test something like this, where I say, using this equation, plug in the following pieces. So I need us to get used to plugging in 48 for my velocity and then 3.5 for my S sub O. But I will not have you memorize something like this. I will have to give that to you. Is everybody okay with that? Now, that being said, now that I gave it to us, let's plug 48 in for that V sub O, and we're going to plug 3.5 into that S O. And we're going to need that in order to solve, okay? Letter A says find the equation. That's what letter A is going to be. So we'll say y equals negative 4.9 x squared plus 48x plus 3.5. Letter B says, what's the maximum height the baseball will reach? How many seconds will it take to reach that height? Anytime I see the word maximum, little alarm bells go off in my head and I put it in the calculator. A minute I see that, I go, we're going to graph and we're going to find the max. Graph and max. It's kind of like the theme of today is with these word problems, graph and max. So go to your calculator, go ahead and cancel everything else, clear it all out, and we'll put in negative 4.9 x squared plus 48x plus 3.5. Now I'll mess around with the window in a second, but let's say I just forgot and I just press graph. Let's see what happens if it's a good enough graph for us to see. Okay, this isn't too alarming. Just so we see that tiny little hump at the beginning. I'm just going to tighten up my window so I see that a little bit better, okay? It looks like I could be anywhere less than 300, and 10 is the biggest X I really want. So we'll move that X to 10, and I might even make this smaller, like 200. I feel like I had lots of space up there. Perfect. And again, you don't have to pick the same numbers as me. I just think this is a good enough vision of my graph that I want to see. And I can now easily find my max. So second trait, oh, not min. Second trait, max, left bound, right bound. And I get my X is 4.89. I don't know why I wrote it like that. Let me write it as an ordered point like I wrote all the other ones. 4.897, I guess, whatever. And then 121.05. The problem said, what is the maximum height and how many seconds will it take to reach that height? I'm going to argue we have both of those numbers. Which one's your max height? 121, very good. And then which one is how long it takes to get there? Good, that's your seconds. So if you notice, mostly on these last couple, we just wrote equations and we found the max. We're going to do something very similar with the next two. They're just a little bit different of problem setting up. Okay, does anybody have any questions on what we've done so far? Okay, last two problems. Let's jump up to 58. This one says the Welcome Home Apartment Rental Company has 1,600 units available, of which 800 are currently being rented at $300 per month. The market survey indicates that each $5 decrease in monthly rent will result in 20 new leases. Okay, so the question we're asking ourselves is, what should the price be? How much should we drop the price in order to have the most amount of rentals in our unit? Okay, and we're going to answer that with our equation, and we're going to set it up again a little different than we're used to. We're going to have two sets of parentheses here. The first set of parentheses represents the apartment. So I'm looking at just apartment numbers. The second parentheses is looking at my price. Okay. So it says that we have 1,600 units available. That's nice information, but not super useful, of which 800 are currently being rented. And it says that if we decrease the price, we'll get 20 new leases. Okay. So the current amount that I have right now is 800. And if I drop the price every $5, I'm going to get 20 new leases. So we're going to say, okay, we already have 800. Every time we drop the price, which is that X value, we're going to get 20 new leases. So $5 drop, we'll get 20. $10 drop, we get 40. $15 drop, we get 60. That's about as much mental math as I can do today. Okay, now let's think about cost. How much are they currently being rented out for? 300? Good. This is not a very realistic word problem in this day and age, but that's okay. And then it says a $5 decrease. So am I going to plus or minus this 5x? Minus to show my decrease. Awesome. I know that's a little funny, but notice that I kept my apartments together. I kept my money together. That's the equation I'm going to use. And now I'm going to graph it. Let's see. Letter B says, find the graph for rent levels between 175 and 300. So basically between 0 and 25. So we will see a maximum and we want our X to go between 0 and 25. So let's go put this in the calculator. Exactly as you see it. If you want to FOIL it out, great. I just feel like there's often room for error there. So 800 plus 20x, and then 300 minus 5x. And again, letter B tells us find the graph for this price value, and that means we're going from 0 to 25 for our x's. So I'm going to go over to my window and make sure I'm at least at 25. I don't know what my Y max is going to be, but just because I really don't know, I'm going to put it 1,000 and we'll see what's going on from there. Okay. Whoa. Here. Where's my graph on? Do you guys see a graph on your paper? No? Where's my graph go? I should at least see something. Should I go a lot bigger? No. 20 new leases, 100, 5. Oh, did I ever put a graph in? What's happening here? Wait, one more. I looked at this before I started, but let me just double check my notes. Equation I last year. You see one? It's just extreme. Oh, it's just way lower. Oh, okay.
200,000.
Tell me what your window is again.
My one, that's 2 million.
Oh, 2 million. Okay, so you just think it should be a lot bigger. Okay, let's go 500,000. Okay, we're seeing something now. I want to see a little bit more on my X's. Let me make this X a little bit bigger. Let me go to -10 so I can see a bit of what this graph looks like. Okay. So do you see how we kind of struggled through that? We didn't see a graph because it was way bigger numbers than we were used to. So I said 1,000. I thought I was being like, oh, we'll definitely see it. It was so much bigger. So I have mine now at 500,000, and I have my X's extended a little bit just so I can actually see that peak, see where my max is. And so let's go find that max with us, okay? So let me go back to our normal notes. Now that we've got our picture. So we graphed it, and it was and I might even make a note, like really big Y max. Just so if I see a problem like this on a quiz or test, I don't panic when I don't see the graph. Like I honestly just panicked. Did anyone else panic too? No, just me. Okay, I was panicked. Okay, so I'm gonna find that max, second trace maximum, left bound, right bound. My max says it's at 10 and then 250,000. It says, what rent will yield welcome home the maximum monthly income, okay? So the maximum monthly income is 250,000, that's my income. And then 10 is not the rental price, it's how much we're incrementing either up or down. This is our, like I would say amount of times we minus $5. That's essentially what that is. Okay. So if we wanted to find out what our maximum or what our rental price would be at our maximum income, it would be this expression right here, and we'll plug 10 in for my X. I don't care about how many apartments I rent. All I care about is my rental price. And so we're gonna do 300 minus 5 times 10. So 300 minus 50 is gonna be 250. Okay. For sake of time, we'll just stop there. I have not made the video that you guys need to watch tomorrow yet. If I think about it, I'll try and put D on that video, just so you can see another example and where we know the rent or the window a little bit easier, okay? That being said, you have enough information to do 2.1 for homework. So that's due next time I see you. I am going to tell you, I recommend if you want to turn it in, I'd maybe take a picture of it and submit it on Schoology. I don't know if I'd hand it to the sub. They should put it in this black folder, but I don't trust anybody. So I would just take a picture of it, post it on Schoology so that it's turned in, but you don't lose the physical copy. Did I see a hand over there?